is titled Parametrics. We're going to be eliminating the parameter. So they want us to first solve for t in one of the equations, then substitute to eliminate the parameter, and then last get the y by itself. Okay, so there's a lot of substituting. Think of it's very similar to solving for systems. So like normally when we solve systems in two variables, we either do it by graphing, substitution, or elimination, what some people call linear combinations. The good thing about this, when they give you the two equations, there's actually three variables here. There's the x, there's the t, and there's the y. Yes? Yeah, I will in just a second. I haven't really started the problem. So we're going to first get the t by itself in either of the equations, usually the x equation. Then we're going to, once it's solved for t, we're going to take whatever t is equal to and solve it into the second equation where the t is at. That usually involves distributing, but not always. And then the last thing you do is get the y by itself. Once you get the y by itself, you'll be able to tell what type of equation it is. It'll either be linear or quadratic in like 90% of the time. All right. So here are our examples. So for example number 1, we're going to take these two equations. The first one is x equals 3t minus 1 and y equals 2t plus 1. So I'm going to just rewrite that first equation. The first equation is x equals 3t minus 1. And the point of the first one is to get the t by itself. So we're going to do those inverse operations until the t is all alone. So we're going to do the inverse of subtracting 1, which is to add 1. So we're going to add 1 to this side, which means we have to add 1 to this side. That leaves us with 3t on the right and x plus 1 on the left. Or you could switch sides, it wouldn't matter. And then the t is being multiplied by 3. So the inverse operation would be to divide by 3. Once we divide by 3, we're left with t is equal to x plus 1 over 3. Okay? So that's the first thing they asked us to do. Solve for t. And it's just easiest just to pick the first equation, but you could technically pick the second equation because it also has a t in it. Okay? Now we're going to take whatever that t is equal to, and we're going to substitute it into the second equation. Okay? So in the second equation, we had y equals 2t plus 1. So instead of writing t there, we're going to put parentheses and plug in that x plus 1 over 3. So there would be a t right here, but we're substituting in, so we just take that, plug it in there, okay? And then like I said, usually involves distributing. Guess what? It involves distributing. So we're going to go t times the x, which is, 2 times the x, which is 2x, 2 times the 1, which is 2, all over the 3. Then in order to add these, I'm going to rewrite my 1 with a denominator of 3 so that I have common denominators. And then I can combine my like terms and I get 2x plus 5 over 3 for my final answer of y equals. And then this is in linear form. Okay, you could rewrite it as 2/3 x plus 5/3, and then you would recognize it as a line. You would graph it because it's in the form y equals mx plus b. Okay. Any questions on example number 1? Okay. Example number 2. All right, here's example number 2. Our first equation is x equals 1/2 t, and our second equation is y equals 2t squared. Okay, so I'm going to take the first equation, which is x equals 1/2 t, And the first step is to solve for t. Okay? So if t is being multiplied by 1/2, the inverse operation is to multiply by 2. Or the other way to think of it is that t is being divided by 2, so we need to multiply by 2. So we multiply that side by 2, we have to multiply that side by 2. And then t is just equal to 2x. Once you have one of your equations solved for t, you're going to substitute it into the other equation. So we're going to take that 2x and we're going to plug it in here. And so we're going to have y equals 2x to the power of 2. And then 2x times 2x is 4x squared. And that's our final answer. So we have y equals 4x squared. Hopefully you recognize that as a quadratic, so it's in the form of a parabola because it's in the y equals x squared. That one looks a little bit easier than the first one because there aren't as many steps. Okay. Any questions on example 2? Okay. Let's look down at example 3 here. Let me try and cover that so we're not looking at too many things at one time. Okay. All right, so for example number 3, notice that we still have 2 equations, but then below it, we have some restrictions. Okay, so our first equation is x equals 2 plus 1/3 t. And our second equation is y equals 3 plus t. And then it's giving us a restriction that t is going to be between 0 and 6. And we have the equal part, so it actually includes 0 and 6. All right, so the first step, we want to take our first equation, which is the x equals 2 plus 1/3 t, and we want to solve for t. Get t by itself. So that 2 that's being added, let's subtract it from both sides. Okay, that leaves us with 1/3 t and the x minus 2. And then the inverse operation of dividing by 3 is multiplying by 3. So we have to multiply both sides by 3. And then obviously the 1/3 and the 3 will cancel, leaving us with just the t. And then over here, we've got to distribute. You probably need to distribute on almost all of them. So 3 times x is obviously 3x. 3 times -2 is -6. Okay? Once you get the t by itself, you're going to substitute it into the other equation that you didn't use. Okay, so we didn't use the second one, which was y equals 3 plus whatever t was equal to, which was 3x minus 6. And then this one's fairly easy because we're just combining like terms. This is in linear form, right? Obviously going to be a line, okay? And then we need to find, let me shrink it just a tad here, to find the restrictions. So, to find our restrictions, we're going to plug in the t restrictions of 0 and 6, and that's going to tell us what our equation is going to be, okay? And I do that right here, okay? So you take that first equation, and let me shrink it just, there we go. You take that first equation, and I plugged in the 0 first. Okay, there it is. So 2 plus the 1/3 times 0. Anything times 0 is 0, so it's just 2. Okay. Then we plug in the value, the other value, which was 6. So 2 plus 1/3 times 6. So 1/3 of 6 is 2, so 2 plus 2 is 4. And that gives us our restrictions for x. So x is going to be between 2 and 4. Okay, so you're going to see